Hello, my name is Scott Simpson, and today we'll be talking about accuracy and precision. So in front of you, what you see is there are two sets of data, one for student A and one for student B. We have the measurements, so they're taking the mass of some sort of object, and there are some statistics down here. We have an average, a standard deviation, and a percent error. What we're going to do is we're going to discuss what is the difference between accuracy and precision. And then we're going to go into each of these, definition of each of these. How do we calculate these things? And what do they mean in terms of accuracy and precision? So let's start off with some definitions. So accuracy and precision. So accuracy has to deal with how close to the true value we are. So we're measuring something. Most of the time, we do not know what the actual or the true value of the measurement should be based upon that object or whatever we're measuring. But we can get an okay idea as long as we are considering an accepted value. Maybe there's been a large amount of reports and literature of what a certain value is. Maybe your instructor knows the exact value or close to the exact value. So what accuracy is how far away from that true value are we? How close to, we're going to put true in quotes, value you are, or the measurement is, or a series of measurements. Whereas precision has to deal with how consistent are your measurements. So if you measure the mass of an object, and that's your first measurement, then you measure the second measurement, are they consistent with one another? Are they deviating quite a bit? So how consistent are your measurements? People tend to really like to use the example where you have a dartboard. So we'll draw a dartboard. 1, 2, not a very consistent dartboard, but 3 dartboards nonetheless. So let's say we throw 3 darts. Let's comment on the accuracy and precision. So in the first one, I throw 3 darts, bam, I hit 3 bullseyes. Since they're grouped well together, we will talk about the precision and we'll talk about the accuracy of each of these scenarios. So the precision, since the darts are really close together, we have high precision. And the accuracy, we were aiming for that bullseye, assuming we were playing 301 or something like that. We hit 2 of them, we hit 3 of them exactly where we were aiming. So we would also say that the accuracy is high. Now, let's say we throw 3 darts, we were aiming for the bullseye, but our grouping ends up over here. What would we say about the precision and what would we say about the accuracy? In this case, the precision would still be considered high because the darts are all grouped together. There's a small grouping of them. So we had a high precision. But in terms of our accuracy, we were aiming for the bullseye, but we ended up in this quadrant, not very good. So we would say poor accuracy. Now, let's say we throw a couple more. We're aiming for that bullseye again. And we end up in that case. The precision, of course, again, we look how far apart are they. The precision is poor. We could comment differently on the accuracy. So the accuracy of each of the measurements is really crummy. But if we took an average of those positions, what you would find is the average is in the center. So we would say for each of the measurements, the accuracy is poor. We don't do a good job in both cases. Okay, so we have an idea of what accuracy and precision means now. But we have to talk about some of these descriptors. What is an average? What is a standard deviation? And so on. So let's look into the mathematics of each of these. Averages are pretty simple. They're often given the symbol X bar, then X on top. So let's write out some mathematics to describe this. So we're going to divide by the number of samples we have. We have a sum here which says we're starting at the index of 1 and going until we reach the total number of our samples. And then we have x sub I. So what x sub I is it's each individual measurement. So moving back to the data that we have, there would be 4 measurements that we would measure. We would sum up all of these masses and then we'd divide by the total number of samples, 4. X sub I, there would be 3 x's, x sub 1, x sub 2, x sub 3, and x sub 4. So x sub I is that individual measurement. So that's how we would calculate an average. Everyone's pretty familiar with that, I assume. We have deviation. So what deviation is you're taking the absolute value of where you have that individual measurement, x sub I, minus the average. So we take the absolute value of it, so it should always be positive. But remember, this is the individual measurement. So for example, if we wanted to calculate the deviation of student A's measurement 1, we would take the absolute value of 7.222 minus this average. And that would result in the deviation from measurement 1. Note, since we have 4 measurements, we should get 4 deviations out. Now, next we have a standard deviation. And it's often given the symbol sigma. Depending on what book you look in, that will be a different symbol. Some people like to use S. I prefer a sigma. What we do for this is we take the square root. We're doing another summation where we go from n is equal to 1, or excuse me, I is equal to 1 to n, and we're taking the deviation that we calculated, we're squaring it, so we sum all those up, and then we divide by n minus 1, and note that the square root is right in there. Okay. Next, we have another descriptor. We have percent RSV, or percent relative standard deviation. This gives you an idea of a percent-wise of how much does the majority of the data points around the mean, how does that differ? And by mean, I also mean average. So the way that this is calculated is we take our standard deviation, we divide it by our average, and then we multiply it by 100%. Finally, another aspect we're going to talk about is percent error. In this case, for this course, what we're going to say percent error is we have our measured minus our accepted. So this is a value that we know, divided by accepted, times 100%. So this is the value you're going to get from me. The measured is the average that you're going to calculate. Okay, so which of these have to deal with accuracy and which of these have to deal with precision? So when we're discussing precision, remember, precision is how grouped are our measured values. So therefore, standard deviation, and relative standard deviation are properties that are related to precision, where percent error that's discussing our accuracy. How far away from the true value are we? So let's jump back to this data table that I introduced. Wiggle the camera a little bit. There we go. So what can we say? We want to determine which student has a higher accuracy and which student has a higher precision. I've already calculated these values for you, but you should be able to do that for the experiment. So let's look at student A. We have his data. We have the average, the standard deviation, and the percent error. And again, for student B, we have the same thing, average, standard deviation, and percent error. So what could we say about accuracy? Which student is more accurate? In order to answer that, we have to consider the percent error, because remember, we're talking about how far away from the true value are we. So student A was more accurate than student B. And now let's consider student B. What about precision? There we have to consider the standard deviation. If we had a percent relative standard deviation, we could also look at that too. So let's look at the standard deviation. If we look at these values, we can see that student B has a smaller standard deviation, meaning if we look at the data points, most of them are grouped around the mean, or that average that's calculated. Therefore, student B was more precise than student A. However, if you look at the value of student B, they're actually pretty far away. They have a high percent error. So it depends what's more important in some cases. Is the precision more important, or is the accuracy more important? In an ideal world, you would have both in hand. You would be able to be very precise and very accurate. But in some cases, that might not happen. So thank you for watching. If you have any questions, please leave any comments below, or feel free to email me. Thank you.